What if our universe has already touched another? Something is pulling the universe, somewhere beyond the visible structure of the cosmos. Something is happening, not an explosion, not a collapse, but a movement, a subtle drift of entire galaxy clusters toward a point that cannot be seen. Astronomers call it an anomaly. But what if it's something far more disturbing? What if our universe has already collided with another? Chapter 1. The motion that shouldn't exist. At first, it looked like a simple inconsistency in velocity measurement, a minor deviation that could easily be attributed to observational limitation of calibration drift. But as more data was collected across different regions of the sky, the pattern began to take shape, not as random noise, but as a coordinated motion. Galaxy clusters separated by billions of light years were moving in the same direction, not because they were gravitationally bound, but not because they share a common origin, but because something was pulling them, something beyond the observable universe, and this motion, later referred to dark flow, could not be explained by any known structure within the cosmic horizon, because the scale of movement exceeded anything that could be generated by visible matter, dark matter, or even the large-scale structure of the cosmic web. And that left only one possibility. The source of the pull was outside the observable universe, beyond the region that we can see, beyond the region we can measure, and possibly beyond the region we can even conceptualize using standard cosmology. And that idea alone was enough to challenge existing models because it implied that the observable universe is not a closed system, that there are influences acting upon it from beyond its boundaries. And if that is true, then the assumption that the universe is all that exists becomes incomplete because it suggests that there are structures, forces, or even entire systems that lie outside our observational in reach, interacting with our universe in ways that leave detectable signature but no direct evidence. And this was the first clue, not of another universe, but of something that did not belong to ours. Chapter 2. The Great Attractor and the Invisible Wall. As researchers attempted to map the direction of this motion, they encountered a region of space that has long been considered one of the most mysterious in cosmology, a region obscured by the dense concentration of stars, gas, and dust within our own galaxy, a region known as the zone of avoidance, and beyond that veil lies that is called the Great Attractor, a massive gravitational anomaly that appears to be pulling galaxies toward it, yet remain largely unobservable. And while the Great Attractor itself could explain some of the motion within our local supercluster, it could not account for the scale of uniformity of the dark flow, because the motion extended far beyond the influence of any known structure. And as researchers pushed their model further, attempting to trace the direction of the pull beyond the Great Attractor, they encountered something unexpected, a boundary, not a physical wall, but a statistical limit where the distribution of matter began to behave differently. As if the underlying structure of spacetime itself has been altered, and this boundary did not align with any known cosmic structure. It did not correspond to cluster, filaments, or voids. It existed independently, and when simulations were run to reproduce such a boundary, only one class of model produced similar results. Models in which two expanding regions of spacetime had interacted, not gently, not gradually, but violently, creating a distortion that propagated through the surrounding structure, and this led to a hypothesis that, while radical, began to gain attention, that the observable universe might contain the imprint of collision, not between galaxies, not between clusters, but between entire regions of space-time, between what are often referred to as bubble universes. Chapter 3: The Theory of Cosmic Bubbles. To understand this possibility, it is necessary to step beyond the standard of a single universe and into a framework known as eternal inflation, a theory that suggests the universe did not expand uniformly from a single event, but rather that space itself is constantly undergoing expansion at different rates in different regions, creating isolated pockets or bubbles, each of which can evolve into its own universe, with its own physical laws, its own constant, its own structures, and within this framework, our universe is not unique, it's one of the potentially countless bubbles forming within a much larger inflationary field. And while these bubbles are typically thought to expand away from each other, becoming causally disconnected, there is a possibility that in the early stages of their formation, they could interact, collide, or influence each other, and such a collision would not necessarily destroy the universe involved, but it would have left an imprint, a distortion in the fabric of spacetime that could persist long after the event itself. And this imprint could manifest as anisotropies in the cosmic microwave background, a large-scale flow that cannot be explained by internal structure, or as region where the statistical property of matter distribution deviate from expected patterns. And when researchers compare these theoretical predictions with observational data, certain anomalies began to align. Not perfectly, not conclusively, but enough to suggest that the idea was worth serious consideration. That perhaps the universe we observe carries within it the remnants of an interaction with something beyond itself, something that may no longer be visible, but whose influence remains encoded in the motion of galaxy and the structure of space. Chapter 4: The Sky in the Cosmic Microwave Background. Scientists pushed deeper into observational data. They began to revisit one of the oldest model detailed maps of the universe, the cosmic microwave background, the faint radiation left over from the earliest moment after the Big Bang, a nearly uniform glow that fills all of the space. But within that uniformity lie tiny fluctuations, temperature variation that encode the initial condition of the universe itself. And for decades, the fluctuation had been studied with extraordinary precision, revealing patterns that align remarkably well with theoretical models. But there were always anomalies, small irregularities that resisted explanation, one of the most notable being region significantly colder than its surrounding, an area known as the cold spot, and while various explanations has been proposed, from statistical flukes to large cosmic voids, none fully accounted for its properties, but when viewed through the lens of bubble collision models, the cold spot took on a new significance, because simulation of universe collision predicted precisely such features, circular region where the temperature distribution could be altered by the impact of another expanding spectrum region, leaving behind a kind of scar, a mark that would persist across billions of years. And when researchers overlaid these models with actual observational data, the similarity was striking. Not perfect, not definitive, but compelling enough to raise the question that could no longer be dismissed as purely speculative. What if this region of the sky was not just an anomaly, but evidence, a relic of an event that occurred long before the formation of galaxy, an event in which our universe become in contact with another, and that contact left an imprint that we can still observe today. Chapter 5. The shock wave that never ended. If such a collision had occurred, it would have not been a simple interaction, not a brief moment of contact followed by separation, because the nature of spacetime itself means that any disturbance would propagate outward, not just through space, but through the structure of the universe as it expanded, and this raises the possibility that what we are observing today is not just a static remnant, but an ongoing effect, a shockwave that began at the moment of collision and continues to influence the motion of matter and energy across cosmic scale, and this idea began to align with the concept of dark glow, the large-scale movement of galaxy clustered toward an unseen region. Because if a collision introduced an asymmetry in the expansion of spacetime, it could create a directional bias, a subtle but persistent pull that affects structures far beyond the original point of impact. And unlike gravitational attraction, which diminishes with distance and is tied to the distribution of mass, this effect not only be embedded in the geometry of spacetime itself, influencing motion in a way that does not require a visible source, and this could explain why the observed motion appears coherent across vast distances, why it does not diminish as expected, and why it points toward a region that lies beyond the observable universe, because the source of distortion may no longer be visible. Not because it's disappeared, but because it exists outside the limits of what we can see, beyond the cosmic horizon that defines the boundary of our observation. And if that is the case, then the motion we detect is not being caused by something within our universe, but by something that interacted with it in the past and continues to influence it from beyond. Chapter 6. The possibility of different laws. One of the most intriguing aspects of bubble universe theory is the idea that different regions of spacetime could operate under different physical laws, not radically different in every case, but with variation in fundamental constant, the strength of forces, the behavior of particles, and if two such regions were to collide, even briefly, the interaction could create a boundary where these differences become apparent, not as a clean separation, but as a gradient, a transition zone where the properties of reality itself are altered. And while detecting such variation is extraordinarily difficult, some studies have suggested slight inconsistencies in fundamental constant when measured across different regions of the universe, difference so small they could easily be dismissed as measurement error, but persistent enough to raise questions. And if these variations are real, they could be interpreted as evidence that the uniformity of physical law is not absolute, that there may be regions where the rules were taken for granted to shift, and if the regions are connected to a past collision with another universe, then the implications are profound because it means that the structure of reality we experience is not necessarily universal. It may be local, shaped by the history of our particular region of space-time, and that history could include interaction with other regions that operate under slightly different conditions, leaving behind subtle traces that we are only now begin to detect. Chapter 7. The limit of observation. Despite this possibility, there remains a fundamental limitation that could not be overcome: the cosmic horizon, the boundary beyond which light has not had enough time to reach us since the beginning of the universe, and this horizon defines the limits of what we can observe, not because there is nothing beyond it, but because information from beyond it cannot reach us. And this creates a situation where any interaction with another universe that occurred beyond or at the edge of this horizon would leave only indirect evidence, distortion, anomalies, patterns that hint at something beyond but cannot reveal it directly. And this limitation is not just a technical challenge, it is a fundamental constraint imposed by the nature of spacetime itself, meaning that certain aspects of the universe may always remain beyond direct observation, accessible only through their effects. And this is precisely the situation we find ourselves in when considering the possibility of a cosmic collision. We cannot see the other universe, we cannot observe the event directly, but we can see the traces it may have left behind, and those traces, while subtle, are become increasingly difficult to ignore. Chapter 8: The Question of Timing. If a collision did occur, when did it happen? This question is more complex than it might first appear, because in an expanding universe, events that occur at different times can be observed. Events that occur at different times can be observed simultaneously due to the way light travels across vast distances, meaning that what we can see in the cosmic microwave background is a snapshot of the universe as it was billions of years ago, while the motion of galaxies reflects more recent dynamics, and if both of these contain signatures of the same event, it suggests that the effects of the collision span a significantly portion of cosmic history, influencing both the early condition of the universe and its later evolution. And this continuity supports the idea that the collision was not a brief, isolated event, but a process that has lasting consequences, shaping the structure of behavior of the universe over billions of years. And this raises an even more intriguing possibility that the universe we observe today is not simply the result of its own initial conditions, but also of interactions with other regions of spacetime that occurred long before the formation of stars and galaxies. Chapter 9: The Possibility of Multiple Collision. If one collision is possible, then more than one may have occurred, and within the framework of eternal inflation, where bubble universes are constantly forming, the probability of interaction increases, especially in early stages of expansion, and this opens the possibility that our universe may carry the imprints of multiple interactions, not all of which are easily distinguishable. Some may overlap, some may reinforce or cancel each other, creating a complex pattern of distortion that are difficult to interpret, and this complexity could explain why certain anomalies do not fit neatly into a single model, while some observations appear inconsistent or contradictory because they may be the result of multiple overlapping influences rather than a single event. And if this is the case, then the universe we observe is not just shaped by its own internal dynamics, but by a history of interaction that extend beyond its boundary, interaction that have left a layered imprint on its own structure. Chapter 10: The Idea of a Cosmic Boundary. One of the most fascinating implications of this theory is the possibility that there may be regions of space where the influence of another universe is stronger, areas where the boundary between our universe and another is not a sharp line but a gradual transition, and while such regions would be extraordinarily difficult to identify, they might exhibit unusual properties, deviation in the distribution of matter, anomalies in radiation patterns, or subtle shift in physical constant. And while no such region has been definitively identified, the search continues, driven by the possibility that somewhere in the vast expanse of the cosmos, there may exist a place where the imprint of another universe is more directly observable, a place where the boundary of our understanding of reality is tested in the most literal sense. 11. As the investigation deepened, the question slowly shifted from whether a collision occurred to what it means if it did. Because the implications extend far beyond cosmology, they challenge the idea that our universe is a complete and self contained system, suggesting instead that it may be part of a much larger structure, a multiverse in which interactions between different regions of space-time are not only possible but inevitable. And within this structure, the concept of a single, isolated reality begins to break down, replaced by a network of interconnected systems, each with its own properties, but capable of influencing others. And this leads to a profound shift in perspective, because it means that the universe we inhabit may not be defined solely by its own laws and history, but also by its interaction with other regions that we cannot directly observe. And this raises questions that extend beyond science in physiology. And this raises questions that extend beyond science into philosophy about the nature of reality, the limits of observation, and the possibility that what we perceive as the total of existence is only a small part of a much larger and a more complex system. And as we continue to explore the cosmos, searching for answers, we are confronted with the possibility that the greatest discovery may not come from what we can see, but from what lies just beyond our reach, influencing the universe in ways that we are only beginning to understand. And if that is true, then the story of the universe is just not the story of its own evolution, but the story of its interaction with something greater, something beyond the horizon, something that may have touched it long ago and left behind traces that we are only now learning to recognize. And in the sense, the question is no longer simply whether our universe has collided with another, but how many times and what those interactions have meant for the reality we experience today, and perhaps more intriguingly, whether such interactions are still possible, whether the boundary between universes are as fixed as we assume, or whether somewhere beyond the limits of observation, the process continues, shaping not just our universe, but the entire structure of existence itself. Chapter 12: The possibility that the collision never ended. As the model became more refined and the data more precise, a subtle but deeply unsettling idea began to emerge, one that challenged not only the timing of the collision, but its very nature. But because all the previous interpretation has assumed that if two universes collided, the event would have occurred in the distant past, a brief interaction during the early stages of cosmic inflation, leaving behind residual imprints that we observe today. But what if that assumption was incomplete? What if the collision was not a single event, but a continuous process, something that did not happen once and end, but something that is still happening, unfolding at scales and dimensions that are not directly observable? And this idea gained traction when certain anomalies refused to stabilize over time, pattern in large-scale motion that should have smoothed out as the universe expanded instead remained coherent, as if they were being sustained by an ongoing influence. And then these patterns were analyzed alongside models of interacting spacetime regions. They suggested a scenario in which our universe is not only simply expanding into empty space, but is in contact with another expanding region. The boundary between them not fixed but dynamic, constantly shifting, and within that shifting boundary, energy and structure could be exchanged in ways that are subtle yet persistent, creating effects that no creating effects that propagate through our observable universe without revealing the source directly. And if this is true, then the dark flow is not a remnant of a past collision. It is evidence of ongoing interaction, a sign that our universe is still being influenced by something beyond its horizon, something that continues to shape its motion and structure even now. And this transforms the entire narrative because it means that the collision is not part of our history, it is part of our present. Chapter 13. The Invisible Interact. Chapter 13. The Invisible Interface Between Realities. If two universes are indeed in contact, even partially, then there must exist a boundary, not necessarily a sharp edge, but a region where these properties interact, a kind of interface where the underlying structures of spacetime meet. And why such an interface would be possible to observe directly due to the limits of our horizon. Its effects could manifest in ways that are detectable. Subtle distortion in the geometry of space, anisotropy in radiation, and deviation in the behavior of matters that cannot be explained by known forces. And some researchers have proposed that certain unexplained alignments in the cosmic microwave background, sometimes referred to as the axis of evil, could be related such an interface, a directional asymmetry that hints at an external influence, and why this interpretation remains controversial. It illustrates the broader idea that if an interface exists, it may cannot be localized. It may extend across vast regions, influencing the universe in a vast way that is distributed rather than concentrated. And within this distributed influence, the boundary between universes become less like a wall and more like a gradient, a transition zone where the property of region blend into those of another. And if such a gradient exists, then the concept of separate, isolated universes become less absolute, replaced by the possibility of a larger structure in which multiple regions coexist and interact not as isolated not as not not as isolate not a, not as isolated entity, but as parts of a more complex whole. Chapter 14. The possibility of information transfer. One of the most intriguing consequences of a continuous interaction between universes is the possibility that information, not just energy or motion, could be exchanged across the boundary. And why this idea remains highly speculative is it not entirely without precedent. Because in quantum mechanics, information is not bound to classical constraint in the same way as matter and energy, and if similar principles apply at larger scale within the structures of space-time, then it's conceivable that patterns, correlation, or even entire structures of information could be influenced by conditions beyond our universe. And this raises a fascinating possibility that some of the anomalies we observe may not be random or purely internal, but may reflect influences from outside, signal not in the traditional way, signals not in the traditional sense of deliberate communication, but in the sense of structural imprint, pattern that arise from the interaction of different regions of reality, and why there is no direct evidence for the and while there is no direct evidence for such transfers, the idea aligns with the broader theme that the universe is not a closed system, and that its behavior may be shaped by factors that extend beyond what we can observe directly. Chapter 15. The Limit of Understanding. Despite all this possibility, we remain a fundamental barrier that cannot be ignored, the limitation of human perception and the tools we use to extend it, because all observations are filtered through instruments, models, and assumptions that are themselves based on our current understanding of physics. And if that understanding is incomplete, particularly when it comes to phenomena that involve multiple universes or higher dimensional interactions, then our interpretation may be inherently limited. And this does not invalidate the observation, but it does mean that the conclusion drawn from them must be approached with caution, because it is possible that what we interpret as evidence of a collision or interaction is only a partial view of a more complex reality, one that cannot be fully described using existing framework. And this recognition introduces a level of humility into the investigation, an acknowledgement that while we may be uncovering hints of something extraordinary, we are still far from a complete understanding, and that the true nature of these phenomena may live, and that the true nature of these phenomena may lie beyond the reach of current theory. Chapter 16: The Final Realization. As the investigation reaches most advanced state, one idea begins to crystallize, not out of definitive conclusion, but out of perspective that brings together many of the observations and theories into a coherent framework. The idea that our universe is not an isolated entity, but part of a larger, interconnected system of realities, a system in which interaction between different regions are not anomalies, but natural consequences of a deeper structure, and within this system, meet and within this system, the concept of a collision takes on a new meaning. It is not uh, it is not simply an event where two universes meet, but a manifestation of an understanding but a manifestation of an underlying connectivity, a reminder that the boundary we perceive may not be as absolute as they appear. And this leads to a shift in the central question, from whether our universe has collided with another to how it is connected to others, and what those connections imply about the nature of existence itself. Because if universe cannot because if universes can interact, influence each other, and share aspects of their structure, then reality is not a collection of separate domains, but a network, a web of interconnected systems that allow to how it is connected to others, and what those connections imply about the nature of existence itself. Because if universes can interact, influence each other, and share aspects of their structure, then reality is not a collection of separate domains, but a network, a web of interconnected systems that together form something far more complex than any single universe. And within that web, our place is both significant and limited. Significantly because Significant because we are part of a system that extends beyond our immediate perception, and limited because our understanding of that system is still in its earliest stages. And as we continue to explore, to observe, and to question, we may come closer to understanding not just the history of our universe, but its relationship to a much larger and more mysterious whole. And in that understanding lies perhaps the most profound realization of all, that the universe we see is not the entirety of existence, but a window into something far greater, something that continues to unfold beyond the horizon, shaping reality in ways that we are only beginning to imagine. Chapter 17: The Distortion in Reality. As the idea of continuous interaction between universes began to take shape, Researchers turned their attention to something that had long been considered stable, something that was assumed to be constant across all observation, the fabric of spacetime itself, because if two regions of reality were in contact, even indirectly, then the geometry of space might not be as uniform as previously believed. And within certain datasets, particularly those involving gravitational lensing, though inconsistencies began to emerge. Light traveling across vast cosmic distances appeared to bend in ways that could not be fully explained by the distribution of visible or dark matter, not dramatically, not in a way that would immediately suggest a violation of known physics, but consistently enough to raise questions. And when these distortions were mapped, they did not align with known structures, such as galaxy clusters or filaments. Instead, they formed patterns that suggested a deeper irregularity, something embedded in the geometry of spacetime itself, and this led to a new line of investigation, one that treated space not as a passive state on which events occur, but as an active medium that could carry the imprints of interactions beyond our observable universe. And within this framework, the distortions were not anomalies to be corrected. They were they were signals, that not messages in the traditional sense, but indication of a structure that extended beyond what we could see, a structure that might include regions of spacetime, influenced by conditions outside our universe. And as this idea is developed, it began to blur the distinction between internal or external causes. And as the idea developed, it began to blur the distinction. And as the idea developed, it began to blur the distinction between internal and external causes. Because if geometry of space itself because if the geometry of space itself affected by interaction between the cosmic horizon, then the behavior of light, matter, and energy within our universe is no longer determined solely by what exists within it, but also by what lies beyond. And this realization carries profound implication because it suggested that even the most fundamental aspect of reality, the curvature of space, the paths of light, and the structure of gravitational fields might be influenced by something that we cannot directly observe, something that exists at the boundary or even beyond the boundary of our universe. And within that influence, the idea of a collision takes on a new dimension. It is no longer just a historical event, it becomes an ongoing condition, a persistent distortion that shapes how reality behaves at the larger scale. Chapter 18: The Unseen Hand of Another Universe. As the evidence for large-scale distortion grew, a deeper question began to surface, not just whether another universe had interacted with ours, but whether it might still be influencing it in subtle, continuous way. And this idea was not introduced lightly because it challenges one of the most fundamental assumptions in cosmology, that all forces and influences acting within our universe originate from within it. But if the dark flow, the cosmic anomalies, and the distortion in spacetime geometry all point toward influences that cannot be traced to any observable source, then the possibility that those influences originate outside our universe becomes increasingly difficult to dismiss. And within this context, the concept of an unseen hand emerges, not in a mystical sense, but as a metaphor for a system of influence that operates beyond direct observation, guiding the motion of galaxies, shaping the distribution of matter, and subtly altering the behavior of spacetime itself. And this influence does not act like a force in the traditional sense. It does not push or pull in a localized way. Instead, it appears as a bias, a directional tendency embedded within the structure of reality. And this kind of influence is consistent with what would be expected if our universe were in contact with another region of space-time, because the interaction would not necessarily produce visible objects or detectable particles. It would alter the condition under which everything else operates, creating a background effect that permits the entire system, and it leads to a perspective in which the universe is not an isolated entity, but a part of a larger environment, one in which interaction with other regions are not only possible but may be ongoing, shaping the evolution of the universe in ways that are only now becoming visible through careful observation and analysis. Chapter 19: The Limits of Human Perception. At this point in the investigation, it becomes clear that the challenge is no longer just one of the measurement or theory, but of perception itself, because all observations are ultimately filtered through human design instruments and interpreted through human developed framework, and these frameworks are built on assumptions that may not hold when dealing with phenomena that extend beyond the observable universe. And this raises a critical question: how much of what we are seeing is true reflection of reality, and how much is shaped by the limitation of our perception? Because if interaction between universes occur at scale or in dimension that we cannot directly access, then the signal we detect may be only a partial representation. Projection cannot directly projection of a higher dimensional process onto the limited dimension we can observe. And this idea has parallel in other areas of and this idea has parallel in other areas of physics, where higher dimensional theory suggests that what we perceive as three-dimensional space may be a lower dimensional slide of a more complex structure. And if something similar applies to cosmic interaction, then the evidence we observe may be analogous to shadows, patterns that hint at a deeper reality but do not fully reveal it. And this introduces a level of uncertainty that cannot be eliminated. A level of uncertainty that cannot be eliminated because it is inherent to the nature of observation, but it also opens the new door to new ways of thinking about the universes, ways that do not rely solely on direct observation but consider the possibility that reality extends beyond what can be directly measured, and the anomaly we detect may be the only accessible clues to that deeper structure. Chapter 20: The Final Shift in Understanding. As all these ideas converge, a final shift in perspective begins to take place, one that defines not just the specific question of a cosmic collision, but the broader understanding of what the universe is. Because if our universe has interacted with another, if it continues to influence by region beyond its observable boundary, and if the structure of reality itself carries the imprint of these interactions, then the concept of a single self-contained universe becomes insufficient, replaced by the idea of a larger system in which multiple regions of spacetime coexist and interact, and within this system, the boundaries between universes are not absolute, they are dynamic, shaped by the condition of expansion, interaction, and the underlying structure of spacetime. And this leads to a profound realization that what we call the universe may be only a part of a much larger and more complex reality, one in which our observation capture only a fraction of what exists, and in which the forces shaping our universe may extend far beyond its visible limits. And this realization does not provide definitive answer. It does not confirm the existence of other universes or the exact nature of their interaction, but it does change the way the question is framed, because instead of asking whether our universe has collided with another, we begin to ask how it is connected to a larger structure, and what that and what that structure implies about the nature of existence itself, and within that question lies the true significance of the investigation, not as search for a single event or a specific explanation, but an exploration of the boundary of knowledge, an, ex- a- an attempt to understand a reality that may be far more interconnected, far more complex, and far more mysterious than any we have yet fully comprehended. And as that understanding begins to take shape, one thing becomes increasingly clear. The universe is not just expanding into emptiness, it may be expanding within something vast, unseen, and still influencing everything we observe today. The universe, chapter 21. The universe is not alone. It never was. As the pieces slowly came together, a quiet but overwhelming realization began to settle across the entire body of research, not as a sudden revelation, not as a sudden revelation, but something that had been coming all along beneath every anomaly, every unexplained motion, every distortion in the cosmic background. The idea that the universe is not alone, not in the sense of containing life or other civilization, but in a far more fundamental sense that it exists alongside something else, something that had always been there, interacting with it in ways too subtle to notice until the right question was asked. And once the question was asked, the answer did not come as clear signal or direct evidence. They came as patterns, as alignment, as consistency within inconsistency, and those patterns all pointed in the same direction toward the possibility that we observe as the universe is not a complex system, but part of a larger structure that includes regions beyond our horizon, regions that we cannot see but can still influence what we do see. And this influence does not manifest as objects or forces in the traditional sense. It manifests as conditions, as biases in motion, as asymmetrics in structure are subtle shifts that accumulate over time until they form something detectable, and within those shifts lies the evidence, not of a single event, but of an ongoing relationship, a relationship between our universe and something beyond it, something that may be just as vast, just as complex, and just as real, but separated from us by the limits of observation rather than the absence of existence.